something. No? Where am I? Where are all my students? I need more. Students, safe for me. Yeah, very strange radio. Yeah, time to do something. I still need this scope. It's a good scope. rectifiers. We go. Go. Okay. 8 minutes for that. What I have already. Another problem networks rectifiers. First, let's take a look on old style power supply system. In old style power supply system, we would have transformer, rectifier, load, who and what. Okay, so what we got? Old style, network transformer, rectifier load needed DC supply. Let's see. Oh, here they are. Blue line is a load voltage. If we have mass since only absolute value of it, this one absolute value same sign, so DC component and 100 Hz noise component is what we should see on by theory. But here I have planned a current sensor, and yellow line is a current of my rectifier. Okay, I have AC source. Nice harmonic current and pulsing voltage. If we need better quality of DC, what should we do? Filter. We need to add filter. You can see voltage increase, quality. You see, quality of DC improves, but what happens with primary current? Red line, spectrum of primary current. Addition of filter. See what happens? Distortion and observable third, fifth, seventh harmonic. what happens? Why addition of filter causes distortion in primary current? Idea is simple. What happens? At some moment, you have AC source, diode, and charging capacitor. Okay, and here some net resistance. So here is your sine omega star. Voltage of charge capacitor. See, if you have quite good filter, it changes slightly. And current will be somewhere, you will see some kind of peak of current. We don't see sharp rise because here we have transformer inductance. This transient, see, it's a cut of sine, it's a cut of harmonic signal, but it's transformer inductance plays its role. Here is transient in old style power supply network. What will be in new style power supply? New style power supplies do not rely on 50 Hz transformer. To reduce weight and increase performance, how they work? A rectifier is powered from the mains network. Then comes PWM drive, primary reading of transformer, feedback to PWM. In modern designs, transformer is shifted to higher frequency, so there is no inductance on primary side. One moment I will try to assemble something close to modern kind of network. filter. Now, without any filter and without transformer. Ideal picture. And what if I add condenser box? No filter. 20 microfarads. Voltage improves, but this is disaster. Forty microfarads. Filter. Voltage better, but see the form of current. 80 microfarads. Wait 1 second, this one was good. There's no timing. Why you always wait?
You are having lens.
We have shadow. Shadow means what lecture starts 12:30. Okay, where we are? Was gray, black. No, do not explode. Approximately 300 microfarads filters. Voltage improved. Voltage improved, but see what happens with current. It's in form of short peaks. In all the schemes, serial reactance of transformer softens the problem. Here we have sharp charges of condenser. Because resistance of network is much lower. Inertia of network when this capacitor charges is low. We have current in form of short pulses. Even small inductance. Oh, one moment. I will add. I'll try to add. Secondary transformer, secondary winding of my transformer as inductance. You can see improvement. In our small inductance improve. Some computer power supplies will have small 3-4 microhenries inductance inside. This one is better. But without our nowadays reality, what we will get current like this. This kind of current, base harmonic, reach in third and reach in 5 harmonic. It's a current of modern single phase loads. You will see in every modern equipment, you will see DC stage at the input, and DC stage in the input means what current in your network will look like this container. This you see. It's all this nice spectrum. Now deeper. Rectifiers current contain third, fifth, seventh, and so on harmonics, and is in form of short pulses. But this part is simple. At this part we see single phase. What happens if we add transformer? What about powerful loads? More complex stuff. Ground, A, B, C, three-phase network, start and full bridge rectifier. Full bridge rectifier. Frequency inverter or something like this. What will we see in case of power load with full bridge rectifier? This will be A. This is ground. What about rectifier? Where is my full bridge? Here it is, my full bridge rectifier. 6 diodes on to cooling radiator, on to radiator. pēc saraksta 4,05 beidzas.
Paldies.
Tā, koda ir? Jūs. Okay. What are useless all? Yeah. Вот. And one moment, I will connect school. One more wire. Here it is. Only how to say welcome to the circus. Yellow line is current of A phase and blue line voltage of load.
Why the magnitude is different?
They are not in same scale. For about these magnitudes,
Yeah.
why not symmetric? Transformer is beta symmetric. It's natural for such kind of transformer. They have meter lag, magnetic resistance low. Okay, very nice, but missing filters. What do we see now? OA, ring, O, sinus, omega. AC. What do we see? On full bridge rectifier, we are getting like this. 6, we will have 6, 1 to 5, one more, 6. Per one period we have 1 to 3, 1 to 3, here is one ending one period. 6 on the load side, and here is our current.
So if
All
if we put the capacitor here,
one, yes. If we add capacitor, that's what happens when we add capacitor.
it's all not, it will be like DC.
Yeah, at load side, you see, nice DC line. You see what happens on the primary side?
Yeah.
Not one nice peak, but 2. Because we will see current AB, AC, AB, AC for A phase. We'll
It's full bridge rectifier.
Yeah, it's full bridge 6 diodes.
3 phase.
3 phase and star-star connection of transformer. Strangely, this part disappears from most books. Scholars like to show secondary voltage, but primary current, here is other phase is the same. Primary current will have 2 waves, and its spectral composition. Spectral composition is interesting. Here, 50 Hertz. Next one, small third carbon, relatively small. It's magnetizing, it's mostly magnetizing for my current. 250 and 350. 5th and 7th carbon. If I increase load, what can I do? Disconnect ground wire. Big changes. We still have presence of some 150 in phase current. But this mode is relatively simple. I have star-to-star connection. Usually, if we deal with high power customers with high power loads, we will see delta on transformer. One moment I will assemble my transformer with delta connection. This one,
So now it's star connected.
yeah?
Now it's star connected.
Yeah, star to star. Maybe I wait one moment. I will record it. this one goes here. Oh, this one goes. Oh, here they are. Yeah, maybe. Yeah, for comparison. Current in case of delta connection. White line is from star connection, yellow from delta. It's lower, I should increase lower because voltage increase. No problem, I can compensate this scale.
Now it's different.
Yeah. White line is for star connection and yellow for delta. You see, it's much more complex. And if we take a look on the spectral composition, base frequency, small. In theory, it should be zero, but it's not zero. It's magnetizing current of transformer itself, and large 5th and 7th harmonics. In case of delta connection, all this shifts up, and you have not one pulse. But see, it's like double. You have multiple pulses. That's what you will more. This one is most probable picture on the middle voltage side of powerful inverter. This high frequency component will destroy your power correction capacitor, will eat insulation of your cable. This will become a problem. Possible you will need a filter on the primary side. This is problem of what you will see with high power loads needed DC source. Without filter, yeah, I disconnected filter. Without filter, it's nice. But when you add your filter capacitor, you get series of pulses and gain, how to say, effect of delta. Star to star is simplest. You see only pulse from on phase and, how to say, secondary. You have two pulses. Two pulses positive, two pulses negative. Two positive, two negative. In case of delta connection, 1, 2, 3. Positive 1, 2, 3. Negative 1, 2, 3. Positive. Here is reality of node A distribution network. Your load has DC source, DC stage with filter, and that's the current you will get. Okay. Appears what I spent all time in this semester. This is week 16. Friday of week 16. And this means my lecture time is ended. Influence in theory. There was one lecture with measuring instruments, but honestly, it's become obsolete. So I think I will leave it. Yes, indeed. We can leave. We can leave without it. On asymmetric rectifier, we have recording. An example is last object in a learning system. I don't know why, but it moved to the end of the tail. It is it for this semester. And for electronics students. Okay, maybe I have one viewer online. Maybe some questions.
So these like from the delta and the star connections.
This different primary source is capacitor in rectifier. But this difference in how the space are positioned, yes, is because of 30-degree shift in delta. For the 50 Hz, this transformer implies 30-degree shift in, if you have star delta, and delta is on the lower side, 30 degree will be forward. For 50 Hz, for 250 Hz, 30 degree shift will be backward. You can check it. This how to calculate. You will guess this difference because the star delta transformer has a complex transformer rating. It implies 30 degree shift. And the shift is different for 50 and 250 Hz component. Not everyone understands it, but polyphase, in case of polyphase network, connection schematics of group, it's often called a group of transformers. Most popular are delta on 10 kilowatt or 11, star on 0.4, and group 11. What means 11? If you put A phase voltage on 12 o'clock on 04. 10 kilovolt A-phase voltage will look at 11. 30-degree shift between primary and secondary side. For negative sequence, if you have opposite rotation, the shift will be 30 degrees this way. So if you have transformer of 11 group for 50 Hz, it's a first group for 250. Because of opposite phase sequence in fifth harmonic. Fifth harmonic has opposite phase sequence. 7 also goes forward. 9 is a zero sequence, but zero sequence cannot flow in delta. And 11 again. So you always deal with phase shift. And phase shift is different. It depends on frequency.
Which are the other subjects you are writing for? Which are the other subjects you are writing for?
For adaptronics, only this one. For students of power engineering program, smart power systems, there will be also modeling for master stage, modeling and power systems protection.
For bachelor's only this.
For master. These are they are for master program. We don't have foreign studies program at bachelor level power system. It wasn't popular and we decided to close it. It was too hard. Yes. Level of bachelor program for smart power system in electrotechnics theory is so high, but pure bachelor.
People cannot study.
Yeah, it's far away from average level.
Can you show me the which program can I use for the second task?
For second task,
Voltage drop not
yes, for second task, it's named modeling of AC network. Yes, it's called modeling of AC network. In Latvian it was 11, if I understand correctly. It should be watch at the beginning.
Beginning?
Yeah, at beginning can be where are files? There should be files, AC network example, something like this. If I'm correct. Should be somewhere. Numerical DFT applied for stable regime. This one can work.
For the second task. For this.
Yes. DC applied for. It can be also DFT example can be.
DFT. This one?
For solution of rectifier powered network. Yeah, DFT example. This one. This one also works.
In for I and all the things we should edit in this file, right? This
Solution of Jordan, don't touch functions, don't touch function. this part is editable.
Okay.
But watch,
The
take a look, watch the video.
Yeah.
You'll see how I do it. I took it step by step. There should be a video. I recorded video this year too. What was solution of some kind? I solved some kind of network this year. But this program came with video where I solved it step by step.
Okay. I'll try to do like at least one, right?
Do it.
Yeah.
Do it. Try.
Yeah.
They all actually less than an hour needed to solve everything.
Okay.
There should be somewhere a program I solved all variants. All. Yeah, they all sold somewhere. I don't remember on which PC,
Okay.
but once I was angry and I solved all of them. Okay, maybe some questions. I see viewers online. Please ask a question. Because I'm afraid I will disappear till September. I may become bigger. Good chance to ask a question. Paid time of lecture ended. Why it's important? Awesome. See no questions. Last chance. No. No questions. So